Okay, welcome to the FRQ section of our chi-squared review guide. Number 11. This one is, you should be able to note that this is a goodness of fit test just off the start because you have one list of numbers. It means I'm going to be using a list, not a matrix. So the independence and homogeneity, not even on the table yet. But it's asking us to do this test. And we're going to go ahead and let's do phantom, right? So the P is really right there in the paragraph, so we're not going to do that one. My null hypothesis. It says that 5 law firms brought in a certain number of clients. They want to know, do they bring in equal numbers? That's the question. And so my null hypothesis says that all bring in equal numbers. Okay, my HA is just the opposite. Different numbers. Or not equal, however you want to say that. Okay, my assumptions. Remember, with goodness of fit, we want to make sure it's a random selection. And in this case, it's not necessarily random, but we're going to say it's representative. Representative. Independence, we'd assume that the client, the partners have independent clients. And then 10% here. I don't necessarily need to do 10%. There's not necessarily a limit to the number of clients that I could potentially have. So that isn't really a big deal. But it's all, if you put it in, it's not a big deal. But what is a big deal is expected counts. So at this point, I'm going to go in and I'm going to sum all the numbers on the list there because I need to know that total. So 35 plus 42 plus 22 plus 41 plus 30 equals. And then they're going to divide that by 1, 2, 3, 4, 5. That gives me an average of 34, right? So my expected sale counts, it's all 34, which is greater than 5. So we're good on this piece. And we're going to be using a chi-squared GOF test. So let's get our test values. So let's go into my list now. I'm going to enter all these numbers into my lists. And then we're going to do 34, 34, 34, 34, and 34. Go over my test now. I'm going to pull up the GOF test. In this case, I have 1, 2, 3, 4, 5. So 5 minus 1 is a degree of freedom of 4. Make sure you enter that. And hit calculate. And we end up getting a chi-squared statistic of 8.059. We have 4 degrees of freedom. We have a p-value of 0.08947. So my conclusion, we failed to reject the null. Our evidence suggests that bring in different numbers of clients, different numbers of new clients. We'll say an alpha level here, 5. Okay, so that's 11. In 12, So this one's definitely not a goodness of fit. It looks like we're more down to a independence or a homogeneity. So let's read the question. Do these data provide convincing evidence of an association? Instantly we know that's independence, because it's a relationship type of thing. I'm going to go ahead and skip the... Do I need the totals? No, I'm not going to do the totals. What I'd like to do now is, here again, it's going to be, P is the question, H. You would say, what would you say that? I guess experience. And direction. Or independent. That's my null. HA. Experience, level, and direction are DEP. And you're welcome to use those quotation marks. That just means that it's exactly the same as what's written right above it. PHA. So remember, this is independence. There's really, is it random? Let's see. 2 hikers selected at random. Okay, so it was random, so it's stated. I would assume that hikers' levels of experience in the direction they choose, like separately, hikers don't affect other hikers. We're assuming they're randomly chosen, so these are people not hiking together. Okay, and 10% here we have. There's a huge number of these. I did not find the totals here, but 10%, right? It's definitely less than the population, than 10% of the population. Okay, and then finally we're going to use expected cell count. I'm going to go and I'm going to put it in the matrix. And so it's a 2 by 3. This is 20, 50, 50, 10, 30, and 40. Double check. 20, 50, 50, 10, 30, 40. Good. I'm going to go in to and run my chi-square test. I'm going to go ahead and write this down now. So PHA, and this is going to be the, let's do that, chi-square independence. And PHAN T, test statistic in this case is 1.5. My p-value, oops, let me fix that. It's going to be, let's see, chi-square equals 1.505. The p-value is equal to 0.4713. So, you can't take it outside now. To lay down with it? Just pepper around it? What are you going to do? Just take a nap? Oh, yes. Yes, you're welcome to. Okay. And conclusion. So, for my conclusion, failed to reject. It would seem hikers and direction are independent. Right, so we're going to be, I've got to go back and get my expected cell counts if I want to get credit for those. And so expected, sometimes you got to find a place for these. 18, 48, 54, 12, 32, 36. Okay, so in all of these, all greater than 5. So we're good on that. which that shouldn't. You should definitely have rejected the null there. Anyway, it would seem logically that if you're hiking, you would go downhill, not uphill, unless the city you came from was uphill, but that's neither here nor there. All right, let's move on. Okay, the last question is really two FRQs kind of put together. Now, the first one is really tricky. I'm giving you a two-way table, and I'm asking about just A's, B's, and C's for a particular set of grades. What I'm really not telling you is that this first test is a chi-square test of goodness of fit, because I don't care about the teacher. I want you to remove the teacher as an element, as a variable. And so what we're going to do is we just need to know the total for all of these values on the table for A's, B's, C's, and so forth. So I'm going to quickly add those up. And so 12 plus 6 plus 15. So we're going to get 33 here. And we're going to get 24 plus 12 plus 6. And the middle one, we have 42 B's. And then here again, we have 33 C's, I think. 12 plus 18 plus 3. Yeah. And so I'm looking down at the percentages, and I'm like, well, that seems like it's pretty close. Well, we're going to do this. We're going to do a 1. This is my observed value, so 33. 42 and 33. L2 is going to be my expected values, right? So I'm going to have to sum up my totals here. So 33 plus 42 plus 33. So my total sample size is 108. And so if I wanted 30% A's, I'm going to do 0.3 times 108. So 30%. Remember, these can be decimals, so 32.4, and then 0.42 times, if I can type, 0.42 times 108. That's going to be 45.36, and then oh, no, I messed it up. It's not 0.42, that's the number, it's 40%, so 0.4 times 108. Yeah, that's it. 43.2 and then 32.4. So you can see almost just from looking at it, you can tell we're probably going to fail to reject the null here. It looks like they're going to match it up, right? So let's just kind of run down the list. So my HO is grades are distributed as the standard suggests. Okay, and then my alternative, grades are not distributed as the standard suggests. Let's see. Assumptions. This is probably not random, but it's okay because this is only asking about this group, right? So it's representative of this group because it's from this group. So it's representative. Let's assume that students' grades are independent. That makes a lot of sense. And then 10%. There's definitely more than 108 students, right? So we're less than 10% of the population. And expected cell count we've shown already. So they're all greater than 5. Okay, so N we're going to be using, I already said that, GOF test. Test statistic, let's go ahead and run that test. I'm going to enter the values into my lists. 33, 34, 33, 42, 33. Now it's going to be 32.4, 43.2, and 32.4. I'm going to go to my tests, GUF test. Here we have only 3 lists, 3 values, so my degree of freedom is actually 2. Make sure you put that in correctly. And then we get a p-value, a t-score, a chi-squared value, with a point 0.55, or whatever. My p-value turns out to be 0.9726. For once, an extraordinarily high p-value is actually what you would expect. These percentages look almost exactly what you think they should look like. And so we fail to reject the null. Our p-value is greater than any alpha. The grades seem to be distributed like the standard. Okay. So that was easy. That was pretty straightforward. Okay. Now, going back, is there evidence of an association? Here again, I'm doing the same kind of data, but this time we're going to be using all the above in an chi-square test of independence, because now it's talking about being associated. So we've done a few of the assumptions and conditions, so some of that stuff we don't really have to repeat, but I'm going to go ahead and go to my matrix, and I'm going to enter these values into the matrix. So we have a 3 by 3 matrix this time. So we're going to put that in very carefully. 12, 18, 15, 6, and 3. Double check it. 12, 24, 12, 6, 12, 18, 15, 6, and 3. Okay. We're going to go to the chi-square tests. I'm just going to pull it up and have it ready to go, since I've already got them typed in. Okay. Let's talk about the null. You would say teacher and grades are independent. The alternative, teacher and grades are dependent. My assumptions. We've already done random, but it was representative. Okay, and then again, for independence, grades are independent. And that's all I got to do there, except for my expected cell count. And I could have referenced that. I had already done this before, but some people may be coming and looking at this for the first time and just want to see this part of it. So E expected cell. So I don't have this yet, but I'm going to go ahead and write down test name. It's chi-square independence. The p-value, or I left off n. I'm so tired right now. N T. This one's going to be chi-square equals 21.27. The p-value equals. Dang. Give me a second. Chi-square test. It's 0.00028. So in this example, our conclusion, we reject. We reject the null. It would seem grades and teacher are dependent. Or you could have said, it would seem that grades depend on which, the grade distribution would depend on what teacher you had. That would also be a good way of writing it down. Okay, so there's a good way of looking at a two-way table that could be interpreted in one of two different ways. Looking at it in just like the totals, which would give you just a goodness of fit type of test. Or I could look at it, the whole table, and give a independence or even a homogeneity type of test. Okay, so that was about 45 minutes total for me, talking at the same time doing the problem. So I'm going to put this up in two parts. So this is the second part. Hopefully this really helped you. If it didn't, please feel free to email me any questions you have. I'll talk to you guys later.